I would like to say hello to all friends and colleagues from different parts of the world. Thank you all for taking the time to seeing us. I hope you have enjoyed the Code Quality Conference 2023 so far. Here it's around 8:15 in the evening, and my name is Vahid Farahmandian. I'm here and ready to talk about code quality analysis in Azure DevOps pipelines. I was born in Urmia in 1989. I have bachelor degree in computer software engineering from Urmia University and also the Master of Medical Informatics from Tariq Mansour University. I'm an international speaker and a book author, creator member of your .NET community, and also the CEO at Sputa company, and also I'm instructor at Iranian Fartraz Danish Institute. You can always reach me and contact me using my email address located at v.farahmandian@jingat.ir or using my GitHub profile, or even using the LinkedIn or the Instagram at Vahid Farahmandian, or Twitter user using _Jingat. You can read my blog posts in the jingat.medium.com. Also watch my videos in YouTube using jingat.net channel. Without any extra detail, let's start our session and start our talk. I'm here, as I told you, I'm here to talk about code quality analysis in Azure DevOps pipelines. Before diving into the Azure DevOps, let's take a look at what's quality, how we can measure it, what's technical depths, how we can identify them, and how we can define some metrics to manage our technical depths. Of course, one of the primary goals of the DevOps mindset is increasing the follow-up value to end users. To do this, software must be deployed frequently, maybe even multiple times per day. To make frequent deployment possible, two things are very important. The first one is the automation, and the second one is the quality. So what's quality? Quality, in fact, is the totality of features and characteristics of a product or services that bear on its ability to satisfy given needs. Here, the keyword is the ability. We should define the word ability, in which cases we are able to satisfy the given requirements or needs, in which cases we are not able to satisfy them. So what actually makes quality sufficient can differ from one project to other project. So it's not enough to copy and paste our solution from one project to other project and make sure that all our checklists or all our previous experiences will be productive or will be practical in our next project. So it's important to bear in mind that every project has its own challenge and has its own quality challenges. Before quality can be measured, it's important that we first establish how we measure the quality of a software. We need to convert this quality, or we need to convert the quality into quantitative numbers. In order to do this conversion, a common approach to monitoring the quality in software is to gather one or some metrics. Here are some of the most important metrics used in software quality assurance. For example, the percentage of integration builds that fails, or the percentage of code covered by automated tests, or the change failure rate, or the amount of unplanned work, the number of defects that are being reported by users, or even the number of known issues, or the amount of technical depth. I'm going to dive into technical depth and talk about technical depth in details. So what's technical depth? The term that implies a something. It could be time, it could be quality, it could be attention or work, is owned to the solution. So long as this depth is not paid off, you have to pay interest in the form of all other work being slowed down a little bit. Technical depth could have different forms. For example, the code that's not covered by any unit test, or the code that's not written in a self-explanatory fashion, or we have variables with strange naming conventions, or the code that does not adhere to coding principles. We've written a code that's not adhere to the solid principles, to keys, to dry, or other principles, or the classes that are too complex because they have too many variables or methods, or even the methods that are too complex because they have too many statements. These situations can lead us to technical depths. And of course, If we take a look at our back, almost all of us had the experience that we wish to start a project from scratch. Why the project should be in a state that the developers decides to start the project from scratch? What happened to that project? What happened to the source of that project? In fact, if you want to quickly create some code, you take a loan on the quality. When you want to pay back your loan, you pay interest in the form of extra maintenance costs. But when technical debt skyrockets, the interest becomes so large that it can strangle your project. That's the point where developers want to start the project from scratch and write everything. Of course, taking a loan can sometimes be a good decision, but we should and we must have a plan to pay back our loan. And if we have not any good plan for paying back this loan, our projects will be get in the situation where the developers wants to rewrite the projects, and the project's code will be the project codes will have a lower quality. Let's take a look at this circular process. I really like this circular process. As you see in this process, let's start the process from the custom points, from, for example, lower productivity. Suppose that we are in a team and we see that our productivity is very low. What will happen when the team's productivity is low? Of course, the managers will put pressure on their team to increase the productivity. They will put extra stress on their teams. They will make their teams to work harder. Even they should work on their off days, on their holidays, to make the productivity better, or to improve the productivity of team. But this pressure itself leads to high technical debts, because we need to do more work in a very small amount of time. This high technical depth itself will lead to low morality and motivation in the team, and we will face with the human resources who are not moral or motivated anymore in their work. The lowering the morality or lowering the motivation itself also will lead to the low productivity again, or it could be leads to the low code quality, and then low code quality also leads to the lower productivity. As you can see, when the technical debt, or when the productivity is low, or the technical debt's volume is high, everything in the project is in a risk of a failure. So it's very important to take the technical debts, to pay attention to the technical debts in our projects. There are many tools in the market to analyze the code metrics, or to convert the quality to some quantitative numbers. For example, in .NET, we have a .NET analyzer, which can calculate the code metrics in our code. The .NET Code Analyzer can calculate the lines of code, the cyclomatic complexity, or it can compute the class coupling, or it can compute the depths of inheritance in our code. But as you take a look at these factors, you might find out that these factors are not enough to get good information, or to have a good insight about our technical debts. For example, among these factors, we did not say anything about the security hotspots, or about the bugs, or about the security breaches inside our code. So in this session, what I'm going to show you is a very well-known tool. I'm going to introduce a very well-known tool named SonarQube. Of course, you all might be introduced to this tool. I'm going to show you how you can use the SonarQube to analyze your code and to extract the different code metrics from your code, and also how you can integrate the SonarQube into your Azure DevOps pipelines, how you can manage your pull request mechanisms, how you can define quality gates inside your pull request process, how you can manage your branch from lowering its quality. So with this introduction, let's get started with the SonarQube. I've install the SonarQube in my local host. Of course, in your production, it's not preferable to install SonarQube in your local host. It would be better to install the SonarQube in your, of course, one of your servers, and of course, it might be better to separate the SonarQube web application from SonarQube database. In this presentation, I have SonarQube on my computer. Also, the databases are my computer. So let's take a look at the SonarQube configuration. After extracting the SonarQube in your computer, you can navigate to the folder named conf. And if you open the conf folder, there's a very important file here named sonar.properties. Let's open this file and take a look at the file, what's inside this file. As you can see, at the initial phase, all of the lines of this file is commented out. But if you take a look at this file, there's a section for database configuration. You can configure the SonarQube for to work with different kind of databases. For example, it can work with Oracle databases, it can work with Postgre databases, with SQL Server databases, or with many more databases too. After configuring your databases, you can configure your SonarQube web server. You can tell the SonarQube to use which host configuration, or to listen on which port number. After configuring the web server, you might need to, as you can see, as I'm sliding this file, you can see that SonarQube have SSO authentication support, it have LDAP configuration support. It has Elasticsearch. Of course, SonarQube in the backstage is working with Elasticsearch. You can configure the Elasticsearch and define the port number or the host number of Elasticsearch to connect the SonarQube to your custom Elasticsearch databases, or even you can configure the logging mechanism in SonarQube and many more configuration that you can have inside your SonarQube. I'm going to run the SonarQube using the in-memory databases because I'm going to have just a demo of the SonarQube to you. So let's close the SonarQube. In order to start the SonarQube and make the servicing, you can navigate to the bin folder inside your desired operating system folder. For example, inside the Windows folder, there is a file named *sonar.bat. If you run this file, after some time, you will see that SonarQube is getting up and starts servicing to you. And if you navigate to the local host, the port 9000, this is the predefined and the default port number for SonarQube. Of course, you can change the address and port number of SonarQube, as I mentioned before. You can reconfigure this configuration using the sonar.properties files. Okay, as you see, my SonarQube is up and it's running. It's ready to analyze my source code. Okay, it's enough up to here. Let's get back to my source code. I have a sample source code here, which has some different code with different code smell problems. For example, the cyclomatic complex.cs file is a CS file with a method which has a high cyclomatic complexity, or there is another file named depths of inheritance, which is a sample file. It's going to show me that some classes have very huge depths of inheritance inside them, or duplication 1 or duplication 2 are two codes which are exactly the same with each other, and I'm going to find out these duplications during my quality gates. Or I have a lines of code file, which is a method with huge number of files. As you can see in this method, clearly it's not adhere to the solid principles. For example, I have a method named calculate, but the method calculate itself is going to doing the shipping cost duty, or it's responsible for the total order cost calculation duty. Of course, in order to rewrite this method, it would be better to separate these implementations. But as I told you, these are some demo source codes, and I'm going to show you the problem inside these codes using the SonarQube code analyzer. And I have a program that's CS file, a very simple file. I have committed this code into my Azure DevOps located at dev.azure.com/Farahmandian/git quality 2023. I've also created a build pipeline for my source code. The name of my build pipeline is PR validation pipeline. It's only the name of my pipeline. Let's edit the pipeline to see what's inside my pipeline. It's very simple pipeline with one build task. Apparently, it will only build my source code without doing any source code analyzing. This is my sample pipeline. Again, let's navigate to the branch section of my source code. I have a main branch, which I assume it as my production branch or as my principal branch. Of course, as this branch is my principal branch, I need to protect this branch from unintended or from lower quality codes. In order to protect my branch, I need to click on these three dots and navigate to the branch policies page. In branch policy page, as you can see, I have previously configured some branch policies on my main branch. For example, I've defined that in order to change to be merged into my main branch, the pull request should have a required minimum number of reviewers. And I specified that one reviewer should review the change before merging the source branch with my main branch. And if I slide down this page, there is a very important section inside this page, is build validation section. Build validation section here, of course, I'm going to use this build validation to build the change before merging the change into my main branch. It's very useful to do the code analysis in this point of the pipeline. For example, when a pull request has been registered from developers, before the pull request could be merged into the main branch, the build validation process will start, and it will automatically start building my project. It will automatically analyze my source codes and checking the quality gates. And if everything's okay and everything seems to be valid, then the pull request could be completed. In this build validation, I've linked my build pipeline with build validation. As you can see, the PR validation pipeline is linked in build validation. If I click on this, I can see that this build policy will be triggered automatic whenever the source branch is getting updated. And this policy is a required policy. It means that if this policy fails, no one can force continue the pull request mechanism. It's required and it should be done for all pull requests among my pipelines. After defining some branch policies over my principal branch, I need to manage the permissions on this branch. So again, I need to click on three dots on my main branch and navigate to the branch security section. In the branch security section, as you can see, I've removed the contributor user groups from this branch. It means that the developers or the users who are member of the contribution security group are not able to push change directly to the main branch. If we navigate to the project settings and go to the permission or go to the repository section, I can see the code quality conference repository here. And if I go to the security section, I can see that the contributor security group has access to create branch. It's very important in this pipeline. It means that any contributor can create their own branch, plus, as we have defined previously, the contributors does not have access to contribute on main branch. However, the contributors totally have a contribute access. They can contribute in this repository, but specifically they cannot contribute to the main branch because I've removed their access from the main branch. So totally, this permission set means that the contributors totally can contribute to this repository. They can create branch, but they cannot contribute to the main branch. So if they want to send their change to the production, they need to create their own branch. They need to define a new pull request. So when the pull request has been created and registered, my pipeline will start running and will start analyzing my code and the quality gates with checking the criteria, the rules, and different metrics, and will check different metrics. And if everything will be okay, the pull request could be merged with the main branch. And after merging the pull request with my main branch, the production continuous integration pipeline or continuous delivery pipelines can sort it and deploy the codes to the production environment. So this is an overall descriptions of the mindset we are going to follow in this session. So let's get back to the pipeline. Let's go to the edit mode of pipeline. As I told you, I have my pipeline here. It has only build task in my pipeline. There is no code quality checking inside my pipeline. So I need to change my pipeline. I need to add the SonarQube to my pipeline to check my source code and to analyze the quality of my source codes. In order to add this SonarQube to my pipeline, it's really easy to work with SonarQube. First, I need to log into the SonarQube. At first page of the SonarQube, I can select I can tell the SonarQube where my source codes have been located. Apparently, my source codes are located in Azure DevOps. I click on Azure DevOps. It will start logging me into Azure DevOps, checking my repositories and listing all my repositories here. I can select and tell the SonarQube to analyze which of my repositories. Of course, I'm going to analyze the code quality COM 2023 repository. I select it and then click on setup selected repository. Okay. At the next stage, the SonarQube asks me, how do you want to analyze your repository? Of course, I'm going to analyze my repository using the Azure pipelines. I can select other CIs. For example, I can analyze my source code in other continuous integration tools, but I'm going to analyze my code using the Azure pipelines. I select Azure pipelines. SonarQube will navigate me to the next page where step by step it will direct me to configuring my pipelines in order to connect it to SonarQube and start analyzing my source code. So click on continue. As SonarQube said, you need to define a service connection in Azure DevOps. Of course, we use the service connections in Azure DevOps to connect the Azure DevOps to any third-party tools. Of course, SonarQube in place is a third-party tool, so we need to connect Azure DevOps to SonarQube. In order to make this connection possible, we need to define a service connection. As it said, I need to go to the project settings page and also navigate to the service connection menu. Okay, let's go to the service connection. Let's duplicate this tab. Okay, go to the project settings. I need to go to the service connection section. Okay, here it's tell me that create a new connection of type SonarQube. I need to click on create service connection, and from this list select the SonarQube. The next step is tells me that enter your SonarQube server URL. Of course, my server URL is HTTP localhost 9000. I copy this URL and paste it in the server URL section. Then I need to provide a token. This token is used to authenticating the Azure DevOps SonarQube in the backstage. In the fifth step, it tells me that copy the generated token to your Azure DevOps. So let's click on a generated token to generate a new token, and then copy this token and paste it in the token field. Then I need to give my connection a name. For example, let's name it as my Sonar, and grant access to all pipelines to use the service connection and save the service connection. Okay, then let's click on continue. The next step, SonarQube asks me that what type of source code you are going to analyze. Of course, this section has the direct dependency with the license, with the SonarQube license which you are using. SonarQube has different licensing mechanisms. For example, it has developer edition, it has enterprise edition, it has data center editions. These all licensing has some difference on the supported language. I'm using the enterprise edition of SonarQube on my device, and I can select the .NET as my codes. Of course, as I showed you, my source codes have been written using the .NET framework. I click on .NET framework. Again, SonarQube step by step starts illustrating me how can I use the SonarQube inside my pipeline. Say that in Azure DevOps, create or edit a build pipeline. Okay, we have a build pipeline, so we need to edit our pipeline and add a prepare analysis configuration task before your build task. This sentence is very important. You need to put the prepare analysis configuration before your build task. So let's get back to the pipeline. Click on my agent job and add a new task. I need to add a SonarQube prepare task. It's here, prepare analysis configuration. Let's add it to my pipeline. As I told you, you need to put this task before your build. In order to configure this task, I need to tell this task to connect to SonarQube using which service connections. In this drop-down menu, I can select the Sonar service connection, which I have created so far. I select my Sonar connection here, and in project key section, I need to again provide another token to my pipeline, which distinguish my project from other project in the SonarQube. If I get back to the SonarQube, it provides me the project key here. As you can see, I copy this SonarQube key and paste it here. The rest of the configuration for prepare analysis on SonarQube are optional, so I ignore them and I continue to design my pipeline. And the third step, in the second step, SonarQube told me that add a new run code analysis task after your build task. So I'm going to add the Sonar code analysis after my build task. It will collect my build results. It will be start analyzing my source codes. And if I want to publish the code analyzing results inside my build pipeline, I also need to add the SonarQube publish task to my pipeline too, as stated in a third step. Add a new publish quality gate result to your pipeline. Of course, adding this task to your pipeline is optional. As I said, if you want to publish your code analysis result inside your build pipeline, you need to add the publish SonarQube task. If you do not need to publish your SonarQube results into your build pipeline, you do not need to add this task. You can omit it from your pipeline. But let's add it to our pipeline and see what's its impact. Publish quality gate result. I'm going to add it to my pipeline. As you can see, run code analysis and publish quality gate results has no configuration, and we do not need to configure them in order to work with SonarQube. Any configuration needed to analyzing our codes is placed in the prepare analysis on SonarQube and in SonarQube itself. After preparing our build pipeline, I can click on finish this tutorial. And again, as you can see in the SonarQube tells me that it's waiting for the first analysis to come in. Okay, let's save this pipeline. Now I have a pipeline with a prepare analysis, the SonarQube, build task, run code analysis, and publish quality gate results. And as I stated before, this pipeline, I have added this pipeline to my branch policy. Here in branch policy menu, I've linked it to my build validation. So this pipeline will start during the pull request. And also, please take into account that this pipeline in the trigger section does not check. We do not need to check the enable continuous integration checkbox here, because we do not need to trigger this pipeline whenever our branch has been changed. We're going to run this pipeline whenever pull request has been registered. So we do not need to select enable continuous integration checkbox here. So our pipeline is ready. Let's get back to the source code and let's create a new branch. I'm going to create a new branch. Let's call it, for example, feature 1. This branch is based on the main branch. Okay, then go to the feature 1 branch and let's change our code. For example, the cyclomatic complexity. I'm going to change this code. Okay, and commit my change to the feature 1 branch. Okay, now suppose that our change have been finished and I need to register a pull request in order to merge my change with main branch. So let's get back to the branch page. Here in the branch page, in the branch grid, you can see that my feature 1 branch has one change which is not located in the main branch. In order to merge them, I need to define a pull request. Let's click on these 3 dots and select the new pull request, and then click on create. Okay, I've created the pull request, and as you can see, the build validation pipeline has started checking my source code. Let's click on the details link. As you can see, my PR validation pipeline starts running. I can see the details of pipeline, which is running here too. Let's get inside it and watching what's going on. Per analysis on SonarQube has been done successfully. It's now starts building my project. Okay, it's finished. It starts the run code analysis task. Let's wait until this pipeline invocation has been finished. It's getting finished. Okay, the code analysis also finished and starts publishing the quality gates results. Of course, putting the published quality gates result into your pipelines will impact the pipeline's total performance. So you need to add it if you really need it. Because it will, as I told you, it will impact the overall performance of pipeline. Let's wait to this stage to finish. Okay, it's been finished too. No, it's getting finished. Okay, the pipeline invocation has been finished. As you can see, pipeline executed and run successfully without any error. Let's get back to the pull request. The quality gate also has been passed, and our validation pipeline is also completed successfully. As I showed you, the main branch has a branch policy which require at least 1 reviewer, and it's waiting for 1 reviewer to review the change. After reviewing the change, I can decide what to do with this pull request. To complete it, it means that to merge the change with the main branch, or I can abandon the pull request, remove it, or reject it. Without doing anything, let's get back to the SonarQube and see what's going on inside the SonarQube. If I get back to SonarQube and go to the projects menu, I can see my projects defined here. Let's click on the project. Here in the branch section, I need to navigate to my pull request. If I click on the pull request, I can see that the quality gate has been passed. However, my code has around 14 new bugs are located inside my code. It has 24 new code smells. It has 27.27% duplication on my source codes. And if I click on each of these issues, I can view the details of the issue. For example, it says that let's find, for example, move J into named namespace. If I click it, it will show me that this class is not located inside any namespace. Or I can even go to the other sections. For example, let's take a look at the code smells. For example, it says that the calculate method does not access an instance data and can be marked as a static. I can make this method as a static. Let's get back to the overview. So as you see, I have proposed some change. I've proposed a pull request. After proposing the pull request, the quality gate starts analyzing my source codes, and it told me that the code quality gate is okay. It means that your overall quality of code is okay, and you can proceed with merging your branch, merging your feature branch with the main branch. But as I take a look at the detailed information of the code analysis, I found out that my source code really is not very okay, and I need to reconfigure the quality gates and redefine some rules in order to better protect my source codes. In order to define the quality gates, I can navigate to the quality gate section, and as I can see here, there's 2 different quality gates here. One .NET gate is a custom gate which I define myself, and SonarWay is a built-in quality gate. And if I take a look at my project and go to here in the project section, if I navigate to the quality gate, I can see that my source code is going to be analyzed using the .NET gate. .NET gate itself has only two analyzing mechanisms. It's analyzing my source code based on code smells and duplicate lines. And if the code smells is greater than 3, it will fail my pipeline. And if duplicate lines greater than 5, it will fail my quality gate. But as I can remember, the code smells and duplicate lines of my source code has a number larger than these 3 or 5 numbers. That's because of these sentences that's located here. That's condition on overall code only applied to branch. But we're working with pull requests, so we need to change these metrics. In order to change these metrics, I need to add a condition and say my condition that the condition is going to perform on only new code. New code means that this condition will be applied over my pull request. So in a new code, I'm going to say that, okay, code smells. If the code smells is greater than 3, then please fail the quality gate. Or I can add another condition to my code. For example, if the duplicate code, or if the duplicated lines is greater than 5, then fail the quality gates. Okay, I've changed my quality gate. I can get back to my pull request. Let's abandon this pull request. Okay, get back to branch and propose a new pull request. Okay, create. And again, it starts to running my pipeline and checking my quality gates. And that's what's happening inside my quality gate with these 2 new conditions which I added to my quality gates. Let's wait and see what's going on this pipeline. Okay, it has been finished. Come on. Okay, the pipeline finished finally. Okay. As you can see in the pull request validation process, the quality gate failed, and it signals the reviewer that please take into account that this code does not adhere to the minimum quality definitions that we have defined in our quality gates. So the reviewer, please take it into account, and if you found the quality gate has been failed, please reject the change in order to prevent the lower quality codes to be integrated into our main branch. This is really useful in order to managing our qualities during our pipelines. Of course, we can simulate this process without using any tools. We can check the code quality using our developers or using our tech leads. But these manual procedures always have very limited quality, and they're not really good option for practical and enterprise applications. Of course, using tools in order to automating some processes in our software development will be higher our quality, and it will be gives us a software with lower bugs or with the lower defects inside it.